In the primordial depths of time, roughly 4.5 billion years ago, our planet Earth was a sweltering, molten wasteland. Yet within just 600 million years, life as we know it emerged, a phenomenon that scientists find inexplicable given the harsh conditions that prevailed during that period. The prevailing theory is that life originated in a primordial soup and evolved slowly over time, eventually giving rise to complex organisms and ultimately humans. However, what if we've got it backwards? What if life didn't originate on Earth, but was instead seeded from space, carrying the genetic blueprints of civilizations that existed billions of years before our solar system even formed? That's the question we'll be exploring in this series. We'll delve into the mathematical improbabilities surrounding the emergence of life on Earth, the mysteries of complex biology, and the evidence that suggests life may have arrived here from the stars. Let's start by considering the math behind life's emergence on Earth. The odds of complex molecules coming together to form self-replicating systems are so low that they defy conventional probability. Earth formed 4.5 billion years ago, and for the first 800 million years, our world was essentially a giant lava lamp, constantly bombarded by asteroids and bombardments of cosmic radiation. The surface temperature reached 2,000 degrees Fahrenheit, conditions that would be lethal to any known form of life. Yet somehow, by 3.8 billion years ago, we find evidence of complex microbial life already thriving in the fossil record. This gives evolution just 600 million years to go from sterile rock to living organisms. Charles Darwin himself called this rapid appearance the warm little pond problem. He knew that natural selection needed time, vast amounts of time, to create even the simplest life forms. Yet here on Earth, life appeared almost immediately after conditions became suitable. Consider the complexity we're dealing with. Even the most basic bacteria contains roughly 4 million individual parts working in perfect harmony. DNA, RNA, proteins, cell membranes, energy production systems. It's like finding a fully assembled Boeing 747 in a junkyard where only raw materials existed the day before. Modern scientists have tried recreating these conditions in laboratories. They've mixed all the right chemicals, applied electrical charges to simulate lightning, and waited. The results? A few simple amino acids, the building blocks of proteins. Nothing even close to a living cell. The gap between chemistry and biology remains as mysterious today as it was in Darwin's time. But there's another explanation that makes the timeline make sense. What if life didn't start from scratch on Earth? What if it arrived here already assembled, already tested, already proven to work? Imagine life as a cosmic inheritance, passed down from civilizations that figured out the biological puzzle billions of years before our solar system even existed. This isn't science fiction anymore. NASA has found organic compounds throughout the galaxy. The European Space Agency has detected complex molecules in interstellar clouds. The building blocks of life aren't rare cosmic accidents. They're everywhere we look. The Panspermia hypothesis suggests that life spreads throughout the universe, like seeds on the wind. Some seeds land on suitable planets and take root. Others drift through space for millions of years, waiting for the right conditions. From this perspective, Earth wasn't the birthplace of life. It was just another garden where cosmic seeds finally found fertile ground. If this theory holds true, then every living thing on our planet, including us, carries the genetic memory of civilizations that existed long before Earth was even a glimmer in a stellar nursery. But the evidence goes far deeper than just mathematical probability. Hidden inside the rocks that constantly rain down on our planet, scientists have found something that challenges everything we thought we knew about life's origins. Every single day, Earth gets hit by 100 tons of space debris. Most of these cosmic visitors burn up in our atmosphere, creating the shooting stars we wish upon. But some survive the journey, crashing into our planet as meteorites. For over a century, scientists have been cracking these space rocks open, expecting to find minerals and metals. Instead, they've discovered something far more extraordinary. The Mercus and meteorite changed everything. When this 4.5 billion-year-old rock slammed into Australia in 1969, researchers found something impossible inside: amino acids. Not just any amino acids, but 74 different types, including many that don't exist naturally on Earth. These weren't contamination from our planet. The chemical signatures proved they formed in deep space. Think of amino acids as biological Lego blocks. Every protein in your body, from the hemoglobin carrying oxygen in your blood to the enzymes digesting your food, is built from these essential components. Finding them in a meteorite was like discovering a construction kit for life floating through the cosmos. But the Mercus and meteorite wasn't alone. The Allende meteorite, which fell in Mexico, contained even more complex organic compounds. Scientists found nucleotide bases, the letters that spell out genetic codes in DNA and RNA. The Murray meteorite revealed sugar compounds that form the backbone of genetic material. The Carbon Hill meteorite contained lipids, the building blocks of cell membranes. Here's where things get really mind-bending. Some of these meteorites are older than our solar system. They formed in stellar nurseries, billions of years before Earth existed, carrying their biological cargo across unimaginable distances and time spans. It's like receiving a message in a bottle from civilizations that lived and died before our sun was even born. Recent analysis has revealed something even more shocking. Some meteorites contain microscopic structures that look exactly like fossilized bacteria. These aren't random mineral formations. They have the distinct shapes, sizes, and internal organizations of living cells. The ALH 84001 meteorite, originally from Mars, sparked intense debate when NASA scientists claimed to have found evidence of ancient Martian life preserved in its rocky matrix. The implications are staggering. If meteorites regularly carried organic compounds throughout the early solar system, then the building blocks of life were being delivered to planets like a cosmic Amazon service. Earth, Mars, Venus, and the moons of Jupiter and Saturn were all receiving the same biological packages from deep space. This delivery system is still active today. Every time you see a meteor shower, you're watching potential life seeds rain down on our planet. But survival is only half the equation. For Panspermia to work, these cosmic travelers would need to find suitable conditions for growth once they arrive. The question is whether Earth's fossil record shows any evidence of sudden biological arrivals that can't be explained by gradual evolution. Charles Darwin called it the most serious objection to his theory of evolution. The fossil record, which should show gradual transitions between species, instead reveals something far more puzzling. Complex life forms appear suddenly, fully formed with no clear ancestral lineages. It's like finding modern smartphones in archaeological layers, without any evidence of earlier communication devices. Take the Cambrian explosion, 5 to 40 million years ago. For 3 billion years, Earth was populated almost exclusively by simple, single-celled organisms and basic multicellular forms. Then, in a geological instant, spanning just 25 million years, virtually every major animal group appeared simultaneously in the fossil record. We're talking about creatures with complex eyes, sophisticated nervous systems, intricate shells, and advanced hunting strategies. Trilobites emerged with compound eyes, containing over 15,000 individual lenses, more sophisticated than most modern insects. Anomalous Charis, a 6-foot-long predator, appeared with flexible arms and complex mouthparts designed for processing prey. Where are their ancestors? Where are the transitional forms showing gradual development of these features? Traditional theories struggle to explain this. Some scientists suggest massive volcanic activity created a greenhouse effect. Others propose that early Earth had a much thicker atmosphere. But these explanations require a series of coincidences so improbable that they strain credibility. The Panspermia hypothesis offers a different explanation. What if Earth's perfect conditions aren't accidents but engineering? What if advanced civilizations, facing the death of their own worlds, didn't just send out genetic material randomly? What if they deliberately chose target planets and modified them to be suitable for life? Imagine a universe where planets are nurtured and prepared for life, like cosmic gardens tended by advanced civilizations. This series will delve deeper into this intriguing hypothesis, exploring the evidence that supports the idea of cosmic seeding and the implications of such a universe for humanity's place in the cosmos. Join us as we uncover the mysteries of life's origins, challenge our understanding of evolution, and explore the fascinating possibility that we might be the aliens.